today. Day 2 of inverse functions. Right there. Day 2 of inverse functions. So we already did this. Alexis did it perfectly on problem 43, the board problem. It was written as f of x equals x to the fourth. Well, f of x, we could treat that as y equals. But then inverse notation is that -1. So this is, we already talked about this one. But read it as f inverse of x. Don't say f to the negative first power, because it's not an exponent. It's just notation for the inverse. And this one specifically, it's with f of x. So the inverse of f of x is f inverse of x. The inverse of y is y inverse. Okay. Let's talk about domain and range again. And now domain and range of inverse functions we're going to bring in. So this one I say, find the domain and range of the original function. Okay, let's do that first. Square roots of x minus 3. Let's do that first part. So first off, square root of x. What does just the square root of x, what's that graph look like? Riley, what's that graph look like? Square root of x. But a parabola. It's a dotted line, remember, right here? I know this is a mess, but it's this dotted line. So like I said, we're getting to the point now where we're comfortable. We know what x squareds are parabolas. X cubes, we should know are that S shape. Square root of x is another one that you should get comfortable with. And again, it can never be negative. Okay, so it's never going to fall down here, so that's an indicator as well. And it's never going to be an x value that's negative, so it's never going to be on that side. If it's a negative of, that's where we get into that other thing. So square root of x looks like that little piece going off. What would x minus 3 do to this graph? If I change it up to x minus 3, is it going to move it up or down? Nope. Is it going to move it left or right? What direction? Right. So this is going to go here at 3 and then have that little shape going up. Okay, so that's our graph. The domain of this graph. Can I have 0 as an x value as an input? Nope. What's the smallest number I could have, Cole? 3. Okay. And am I going to include 3 or not? We're going to write it in interval notation. Yes. Okay. Because if I put 3 in here, I end up with 3 minus 3, which is 0. Square root of 0 is 0. That's a number. Okay. And we could even emphasize that by putting a big dot right there at 3. That is defined. Okay. And this one's continuing out to the right. So this is going all the way out to infinity. And we put a parenthesis around that. What about the range? Now thinking vertically. What's the, well, is there a restriction on the range? Yep. Ben, what could you say? Can you be -1?
No.
Can I be 0?
No.
Okay. I can be 0 or I can't? I can. Okay. So this is 0 inclusive going all the way up to infinity. So this is domain and range, excuse me, of this original function. All right, so we got that done. Check mark on that first part. Find the inverse. So this was y equals square root of x minus 3. So we're going to do our switch. Square root y minus 3. This one I will square both sides. On the right, all I'm left with is y minus 3 on the left, do I have x squared or do I have plus minus x squared? Okay, all it is x squared. When you square rooting, like to undo a squaring, plus minus comes into play. This is just x squared. Now, we know a value that we could put, well, we're gonna work from here in a minute. Okay, so I have x squared equals y minus 3, no plus minus there. So x squared plus 3 equals y, and I'm going to use my notation y inverse. And it started out in terms of f of x, so I'm going to say f inverse of x. I'm going to say all these are equal to each other. It's the same thing. Now, let's think of this graph. X squared plus 3. Okay, we know that's a parabola, and we're going to be right here. So x squared plus 3 is going to look something like that. Okay, but my original domain was restricted. Okay, looking at this one, let's start out with the range. What's the range of this parabola function? What's the smallest number that I can have? 3. What's the biggest number I can have? Huh. Look at that connection between those two. The domain of the original becomes the range of the inverse. And then the domain of my inverse is actually going to go from 0 to infinity, and it's inclusive. So really, all I'm going to be working with is this half. Okay? Which again, makes sense. If I were to graph these on the same coordinate axis, I would have had this red one looking like this. I would have my line y equals x, and then my inverse looking like that. All right, they are reflections of each other across there. All right, so our domain was actually restricted on the inverse based on our inputs. But the only thing you have to remember, domain goes to range, range goes to domain every single time. And here's graphically showing why it happens like that. To find the domain range of the inverse, right here. Determine if the inverse is a function. We didn't answer that question yet. Is the inverse a function? Is this a function? Yeah. Okay, again, we could do horizontal line test here. Passes that, it only touches one place. But we know from a definition of a function, we can also do vertical line test on this. Works, okay? So, yes, f inverse of x is a function. All right, let's do another one for practice. Find the domain and range of this original function. Okay, so I'm going to challenge you to think of this one in your head without me actually graphing it on here. 3x squared plus 1. Okay, start to get a mental image of what that would look like. Okay, everybody should have a parabola opening up, and the vertex is right there on the y-axis at 1. So what's the domain of this original function? Could have anything. Okay, it's a parabola opening up. So this is negative infinity all the way to infinity, and we can write it in interval notation. Let's just work from interval notation today. What would the range be? Am I limited on how small I can go with my range? Yep. Marcus, how small can I go? 1. Okay, so this, and it's 1 inclusive all the way to infinity. All right, now let's actually do the work and find the inverse of this one. So first thing I'm going to switch 3y squared plus 1. And so I have x minus 1 equals 3y squared. Divide each side by 3. And then I want to undo my squaring here on the right. So I have just a y on the right. Do I have plus minus on the left? Yes. Okay. The square rooting brings in plus minus. The last problem, we did a squaring to eliminate the radical, so we went the other direction with it. So this is plus minus square root x minus 1 all over 3. All right, that's y inverse, which is the same as f inverse of x. Yuck. That's one that's a lot harder to picture. Okay, we're trying to identify a domain and range of this. And now we have plus minus square root of x minus 1 all over 3. That's a lot harder to picture. We put it into decimals and actually see what it looks like, but that's a lot harder to picture. But we know we just make this little cross going on here, and it's going to be from 1 to infinity and negative infinity to infinity. That's all we have to do. Peyton. I don't know what this one is offhand. 3x squared plus 1. 3x squared plus 1 as the parabola opens up here at 1. And it looks like that. Okay, so based on the first one, it's easier to identify a domain and range. Second one, we can find the inverse function. I'm not even sure what it looks like. I'd have to put it into decimals to see exactly what that graph looks like. Alexis.
So is the number like before the x squared?
This 3?
Yeah.
Okay, so that 3x squared does do something. Okay, does that 3 make the parabola wider or I'm sorry, wider or narrower? Narrower. Okay, still the same shape. Okay, it's just going to squeeze it together because it's 3 times x squared, so it's shooting up faster. So that's how I remember it's narrower. If it was like 1/2 x squared, it's going up half as fast, and so it makes it wider. Okay, but it does not do a shift. I think that's what you're asking, if it shifts it at all. It does not do a shift. All right, now let's do some music. Composing inverse functions. Okay, so the original function, f of x is 2x minus 4. First one, find f inverse. Okay, you do. Tell me what f inverse is if the original is 2x minus 4. Okay, so we get to the point where we get x plus 4 divided by 2 equals y, or I even use new notation to say y inverse. Y inverse is the same thing as f inverse of x. So 1/2 x plus 2 would be the inverse. Now composition of functions. So if I put 3 into my inverse functions, remember I want to work inside out. So I'm focused here on this f inverse of 3. And so this is going to become 1/2 of 3 plus 2. So 3/2, which as a decimal is 1.5. 1.5 plus 2 is 3.5. So now I want to take that and I'm going to evaluate f of 3.5. So I do 2 times 3.5 minus 4. So 2 times 3.5 is 7 minus 4, and I end up with 3. Okay, we notice anything about this? Evan? Yes, but you said it completely wrong. You got the right idea. It's not multiplication, okay? It's composition. There's no multiplication going on. So don't. I think you're thinking this multiplication. It's not a multiplication symbol. That open circle means composition. So yes, Evan is correct. When you compose a function with its inverse, you essentially go right in a circle. You come back to right where you started. So f inverse of 3, and then I put 3 back in, I end up with 3 as an answer still. Or, well, in this case, I put 3.5 in, but still. So this one, I will tell you, even if you take f of -7, compose that with the inverse, you end up with -7. All right, so there's nothing fancy about this. If you compose inverse functions, you just go in a circle and you come right back to where you started. Okay, so that is a key piece of information for today. First thing, understanding domain and range, switch. When you're talking about inverse functions, composing inverse functions, go in a circle and you end up right back where you started with. So that number is the answer. Okay. All right. Some problems for you to work on. And then tomorrow, you're all going to be ready to retest. Everybody's going to come in, big long line saying, I want to retest this.